Hi everyone. So this lesson is just an introduction to horizontal circular motion. So before we look at any type of motion, what we need to remember is that the type of motion actually depends on where is that unbalanced force acting in respect to the direction in which the object is moving. So I've got three scenarios here. There are three cars, they're all moving forwards in the same straight line at constant speed. So scenario one, if your unbalanced force is in the same direction as motion, what's going to happen is that this car is going to speed up, it's going to increase its speed going forwards. Okay, in the second scenario, it's like pushing brakes. The first one was like pushing your accelerator while going forwards. In the second one, your unbalanced force is opposite the direction of motion. So what's going to happen is the car's going to go forwards, but it's going to slow down. Okay, and in the third scenario, the unbalanced force is at right angles to the direction in which the car is moving. So what's going to happen here, because the unbalanced force is in that direction, what's going to happen to this car is not going to go in a straight line. Its speed is not going to change, but its direction is going to change and it's going to go in a circle. So the important thing about circular motion is that the unbalanced force is always at right angles to the direction in which the object is moving. So if I draw a circle here, so here's a circle, and I'm just drawing some positions of the object, so they could be in any of these directions. So the instantaneous velocity of something going in a circle is always a tangent to the circle. So this is the direction of the velocity. So the size of this velocity vector is the same, but what's different is the direction in which it's moving is changing. That's why it's circular motion. Okay, now the unbalanced force acts at right angles to this velocity and it is directed towards the center of the circle. And therefore, this unbalanced force has got a special name, and the special name is called centripetal force. Now, what does the centripetal force do? The centripetal force, because it's acting at 90 degrees to the circle, does not have any effect on the speed of the object. So it will continue to go at constant speed because there is no component in the vertical direction for something that's, at 90 degrees. So all it does is to change the direction of motion. Now, whenever there is an unbalanced force, the object will accelerate in the direction of the unbalanced force. And so anything that's going in a circle, even though it's constant speed, is accelerated motion. And the direction of acceleration will be the same as the direction of the centripetal force, and that's going to be towards the center of the object. Okay, and this is called centripetal acceleration. There are a couple of formulae associated with circular motion. One of them is for what is the formula for acceleration, and the other one is what's the formula for centripetal force. Now, acceleration in a circle is given by v squared over r, where v is how fast is the object going and r is the radius of the circle in meters, and v is measured as meters per second. Now, because an unbalanced force causes acceleration, F is equal to ma, we can get an expression for the centripetal force. So just substituting there, you got m, and then the equation for acceleration, v squared over r. So these are the two equations you need to solve problems on circular motion. Now, sometimes the value for v is not given. However, for constant speed, v is equal to d over t, and the distance around a circle is the circumference of the circle, which is 2 pi r, and the time that something takes to go around the circle once is called period. So if you use v equals 2 pi r over t, then and substitute that in any of these equations, you can get the value for acceleration or centripetal force. Okay? Now, just one more thing is, what is it that provides centripetal force? So usually in real life situations, when you're thinking of circular motion, you could think of planets going around the sun. In that case, your unbalanced force is the force of gravity that's holding it in orbit. Or you could have a ball on a string and you could twirl it around your head in horizontal circle, and here the centripetal force is given by the tension in the string. Because if the string had to break and the centripetal force was no longer there, it's not going to accelerate anymore, it's not going to change its direction, but it's going to go straight. Okay, and then if it's in the air, because of gravity, it's going to come down. And then the other one is, what about a car that is on a curve, okay, or going in a circle? So cars, what is in contact? The tire is in contact with the road. So it is friction between the tires and the road that provide centripetal force. Now, if you're asked to draw a diagram for a horizontal road, something going in a horizontal circle, so this is usually how the diagram is given. So that is your circle. This is your horizontal line. So the force is acting on something that's going in a horizontal circle is, you always have gravity force which acts vertically down, and then equal and opposite that, acting vertically up, is your reaction force. So over here, your reaction force is equal to gravity. So we say that the object is in vertical equilibrium because it's not moving up, neither is it sinking down to the ground. Okay, your unbalanced force acts towards the center of the circle, and that is your unbalanced force, which is provided by friction, and that is your centripetal force. Okay, so I will stop there, and I hope that helped.